All right, so on the last video, part 1, we took a look at rectangular prisms. What we're gonna do now is take a look at some triangular prisms. And we're gonna take a look at the net of a triangular prism and then kind of jump into an example where the net is not given to you. So remember, the net is when you break apart the shape and you unfold it. So if you watched, I believe it was one of the Khan Academy videos on nets, he did a pretty good job of kind of drawing some arrows and step-by-step showing how the shape peels apart. So if I'm gonna try and duplicate that. We'll see how successful I am. So here I see a side triangle, okay? It has a height of 12 inches and a base of 10 inches. Now what I would be doing is I would be peeling this down, and that's where we get this side triangle right here. So again, I'm like unfolding or unwrapping this shape to lay it flat. Okay, so then the same thing is happening to this back triangle, if you can see that. It has the same dimensions, it'll be 12 by 10, and we're peeling that back, and that came right over here. And I like how this image has the letters labeling, so A ended up being on this side, and D is on the opposite side, so it unfolded on the opposite side. They both are connected to this bottom rectangle, E. So this bottom rectangle E, B is that slanted one. I know this is really hard to interpret two-dimensionally, but we're gonna try our best. So the bottom is 10 inches by 18 inches, and that's where E is right here. It's 10 inches by 18 inches. If we take a look at this slanted rectangle, that kind of works its way along the side of the tent. I like to think about it as like that slanted part of the tent. That would be 13 inches by 18 inches. And that's where you get B right here. So if we peeled down B, it would lay flat, and it is indeed connected to E. So that's that connection right there. And the last rectangle is hidden in the back, and you can barely see it, but it's we've got rectangle C back here, and we're gonna fold that back, and that ends up being right here. Whoops, sorry. And that is also, again, it is 13 inches by 18 inches because all of these are the same. So we peel that back and we get the 18 by 13. So how do we go ahead and calculate the surface area now? We do not have 3 identical rectangles. So as much as I'd love to, find the area of one and then multiply by 3, I can't do that. I'm gonna have to do these individually. Oh, although B and C are the same, so we could double those or double one of them, but be careful because E has different dimensions. So let's go ahead and jump in. The 2 triangles are identical. So let's start by saying, hey, let's do the area of the purple triangle. We know area of triangles are base times 1/2 times base times height. So this is gonna be 1/2 times 10 inches times 12 inches. And we get 5 inches times 12 inches, which gives us 60 square inches. That is also the same area as triangle 2. So the grand total area for both triangles will be 120. Okay, let's take a look at area of rectangle E, because it's already labeled for us. We know it's gonna be length times width, so this ends up being 18 inches times 10 inches, and that gives us 180 square inches. Okay, there are no rectangles that are similar to 10, so we need to go ahead and calculate B, and then we can double B to get B and C because they are the same, they have the same dimensions. So the area of rectangle B is length times width, so we get 18 inches times 13 inches. So let's go ahead and crank out that multiplication. I'm gonna just do some scratch work real quick. So we have 18 times 13, whoopsies, going too fast. 3, that's 5, 0 placeholder. All right, 4, 3, 234, okay. So we have 234 square inches. That is indeed exactly the same as the area of rectangle C because they have the same dimensions. So I'm just gonna copy that down and save myself some work. So I have 1, 2, 3, 4, 5 pieces, 1, 2, 3, 4, 5, that I need to add up for the grand total surface area. So that's what I'll go ahead and do for my last step. I'm gonna grab a color I haven't used yet. So we know surface area is gonna be the sum of all of these. I'm gonna go ahead and add those in one step. That's 120 plus 180 plus, I'm gonna go ahead and add those together in one step, plus 468. So we got 8, that's 16, 4, 5, 6, 7 square inches. So your grand total surface area would be 768 square inches. So you find the area of each part and you add up all those areas for the surface area. Let's do an example trying to do this without creating a net. If you want to draw a picture of a net, feel free, but I think at some point it's a good skill to start challenging yourself to do this without nets. But what I'm going to do is I'm going to kind of outline what would be happening in the back here. So I basically just duplicate the front shape and then I connect it to the corners. And that kind of helps me to see that there's a back triangle and a front triangle. Gets a little bit trippy with what triangle jumps out in the front for you, for your brain. It's kind of, just trippy. All right, anyways, let's finish up this last example. So, okay, I see 2 identical triangles, so let's tackle that first. With this triangle, remember, area is 1/2 base times height. Area of the triangle is 1/2 times base times height. So this is going to be 1/2 times 10 centimeters times 8 centimeters. And that's 5 centimeters times 8 is 40 square centimeters. That's going to be the same as area of triangle 2, which would be in the back, is also going to be 40 square centimeters because they are identical. Okay, let's take a look at the triangles, or excuse me, the rectangles on the sides. I actually am realizing I should have given you one more dimension. Let's go ahead and say that this slant height is 10 centimeters. We said that this was 10 and this was 10. We didn't label that one, so assume that it's 10. Okay, so the side rectangle that I can see is 6 centimeters by 10 centimeters. So my area of my rectangle 1 is going to be length times width. So that's going to be 6 centimeters times 10 centimeters. And we get 60 square centimeters. Now, if you notice, the area of the bottom rectangle will also be 10 by 6. That is exactly the same as the side one. So the bottom rectangle is also 10 by 6. That's going to be 60 square centimeters. And the last rectangle that's on the slant over here is also still 6 centimeters by 10 centimeters. So our last triangle is indeed also 60 square centimeters. So to find our total surface area, so SA for surface area, well, it is going to be the sum of the 2 triangles and the 3 rectangles. So the 2 triangles are 80. Let's see, 60, 60, 60, that's 60 times 3, so that's 180. And we add those together. And our grand total surface area will be 260 square centimeters. Hopefully this video helped. If not, shoot me an email with some questions and we will eventually be holding a Zoom on surface area of prisms and cylinders. So that would be another good time to ask some questions.